Hello everyone, this is Sindhu Shri, Assistant Professor, Department of Mathematics, Maharaja Institute of Technology, Mysore. Today I am going to start the Calculus and Linear Algebra. The subject code is 18MATE101. In the last videos, you studied the Differential Calculus 1, that is the Module 1. Today I am going to discuss the Module 2, that is the Differential Calculus 2. So before starting the syllabus, we should learn what is calculus. Calculus is a branch of mathematics focused on limits, functions, derivatives, integrals and infinite series. The calculus has wide range of applications in our daily life. It's used in physics to find the velocity and acceleration of a particle using the simple derivation of the position vector. It is used in chemistry to find the rate of the reaction. It is also used in the biology to analyze the population. It is used in electrical engineering and the space flight engineering. It is used in finance and statistics also. So the calculus has the wide range of applications in our daily life. So it's very important to learn the calculus. The syllabus of the Differential Calculus 2 prescribed by the VTU University. The first you have the infinite series. In that you have the Taylor's and Maclaurin series. The second one is indeterminate form. In that you have the L'Hospital rule. The third one is a partial derivative. Fourth one is a maxima and minima of the function of two variables and its application. The last one is a Jacobian. First I take the Taylor's series. Taylor series or any series is used to find an unknown term, and Taylor series is also used in the power flow in the electrical circuit. The Taylor series is also called the higher mean value theorem. The statement of this consider the function y of x which satisfies the condition. The first one, y dash of x, y double dash of x, the y triple dash of x. Continuation of this, y n minus 1 of x is continuous in closed interval AB. The second condition, the y nth derivative of x is differentiable in open interval AB. Then there exists at least one value C belongs to the open interval AB such that y of B equals y of A plus B minus A divided by 1 factorial y dash of A B minus A whole square divided by 2 factorial y double dash of A. The continuation of this, b minus a power n minus 1, n minus 1 factorial, y power n minus 1 of a. The last term, b minus a power n, n factorial, nth derivative of a. So the Taylor series, consider the function f of x, then it should satisfy these two conditions. The first one, the derivative of first differentiation, second differentiation, third differentiation till the n minus 1th derivative of x is continuous in the closed interval AB. The second condition, it is the nth derivative of x is differentiable in open interval AB. Then there exists at least one value C that belongs to the open interval AB such that the statement shows that y of B equals y of A plus B minus A divided by 1 factorial. The first derivative of A, second one b minus a whole square by 2 factorial second derivative. So the last term b minus a power n divided by n factorial the y nth derivative of a. So this is the Taylor series. So for example, I take the problem expand log x in powers of x minus 1 up to third derivative using Taylor's series. So here the function is the log x. You have to expand in powers of x minus 1 up to third derivative till the third derivative using the Taylor series. In the given function, let's consider the function let y of x equals log x. This is the given function. Up to third derivative means you take the first differentiation y dash of x. The derivative of log x is 1 by x. Then y dash of x. The derivative of 1 by x is minus 1 by x square. The third derivative of x, it is 2 divided by x cube. So minus 2 by x cube, negative will get the positive sign 2 by x cube. Then in the Taylor series, the given powers of x minus 1, here the powers of x minus 1 implies the difference between the a and b, that is b minus a. So this implies b equal to x, a equal to 1. So in the problem, you have to substitute b equal to x and a equal to 1. So the Taylor series expansion becomes the first term y of b equals y of a plus b minus a 1 factorial y dash of a b minus a whole square divided by 2 factorial y double dash of a b minus a whole cube divided by 3 factorial third derivative of a. Next, substitute the b and a terms. So b equal to x, a is 1 plus b minus a, so x minus 1 divided by 1 factorial y dash of 1. Next, x minus 1 whole square divided by 2 factorial y double dash of 1 x minus 1 whole cube divided by 3 factorial the third derivative of 1. Since they asked till the third derivative, stop till the third derivative. So the y of x, they given it as the log x. So y of 1, for y of x you have to substitute, put y x equal to 1. So the y of 1 equals log 1. Log 1 is 0. So the y of 1 equals 0 plus x minus 1. 1 factorial is 1. Y dash of 1, in the first derivative put x equals 1. So the y dash of 1 equals 1. So the y dash of 1 equals 1 plus x minus 1 whole square, 2 factorial is 2, y double dash of 1, in the second derivative put x equals 1. So we will get the minus 1. So the second derivative is minus 1, x minus 1 whole cube, 3 factorial is 6, third derivative, in the third derivative put x equal to 1, so the third derivative of 1 equals 2. So the last term equals 2. This continue the series. So the log x equals x minus 1 is the first term. The second one minus x minus 1 whole square divided by 2. The third term x plus 1 whole cube divided by 3. So this is the log x expansion. The next one is the Maclaurin series. Before start the Maclaurin series, let us know what is the power series and expansion of the function. An expression of the form a0 plus a1x, a2x square, a3x cube, etc., where a0, a1, a2, a3 are the constants, is called the power series. The process of expanding the given function in the form of power series is called expansion of function. So in the Maclaurin series is derived from the Taylor series. In the Taylor series, the last term of the RHS tends to 0 as n tends to infinity. That is, in the Taylor series, for b minus a, you have to put x minus 0. And the last term tends to 0 as n tends to infinity. This is for n tends to infinity. That in the Taylor series, you have to put b equal to x and a equal to 0. You will get the Maclaurin series. You know the Taylor series expansion, that is the first term in the LHS is a y of b. So you write the y of x equals y of a, that is y of 0, b minus a, that is x minus 0, divided by 1 factorial, y dash of a, that is y dash of 0, plus x minus 0 whole square, divided by 2 factorial, the y second derivative of 0. You have to continue like this. So in the Taylor series expansion, if you put b equal to x and a equal to 0, and the last term is 0 as n tends to infinity, you will get the series. That series is called the Maclaurin series. So using the Maclaurin series, you can find the series of trigonometric terms, sine, cos, tan, and the inverse trigonometric functions, exponential functions. First, to consider the series as, let I take this function, let y of x equals sin x. So take the differentiation of this y dash of x, the sin x differentiation cos x, the second derivative, the cos x differentiation minus sin x, third derivative, so sin x differentiation cos x, since you have the negative sign, retain it. The fourth derivative is minus sin x, you already have the negative sign, you will get the positive. The fifth derivative of x is a cos x. So the first term, the y of 0, put x equal to 0, the sin 0 equal to 0, this is the first term. The second one, put x equal to 0, so y dash of 0, cos 0 equal to 1. Next, second derivative, again the sin 0 equal to 0. Third one, cos 0 is 1, since you have the negative sign, you will get the minus 1. The fourth derivative, since you have the sin x, you will get the 0. The fifth derivative of 0, the cos 0 equal to 1. The minimum 3 terms in a series you have to consider. So I consider till the fifth derivative. Then you know the Maclaurin series expansion. The y of x equals, y of 0 is the first term, x by 1 factorial, y dash of 0, x square divided by 2 factorial, y double dash of 0, plus x cube divided by 3 factorial, third derivative of 0. You continue till the fifth derivative. So I go on substituting this term, the y of x is sin x, the first y of 0 is 0, x by 1 factorial, next y dash of 0 you have 1, x square divided by 2 factorial, y double dash is 0, the third term, x cube divided by 3 factorial, the third derivative is minus 1, x power 4 divided by 4th factorial, the fourth derivative is 0, x power 5 divided by 5 factorial, The fifth derivative, you have the plus 1. So if you simplify this sin x, the first term is 0, you will get the x 1 factorial is 1. The second term is 0. Third term, x cube, the 3 factorial is 6. The fourth derivative is 0. The fifth derivative, x power 5 divided by 120. The plus and minus sign. So this is the expansion of the sin x. Similarly, you can do for the cos x and the tan x also. The next series is a tan x series. How to expand the tan x using the Maclaurin series. First you take this function, let y of x equals tan x. Then first one, you put x equal to 0 in this step itself, tan 0 equals 0. So y of 0 equals 0. The second term, differentiate this one, y dash of x. The tan x differentiation, secant square x implies the y dash of 0 equals secant square 0 is 1. So the y dash of 0 equals 1. Next, if you differentiate the secant square, you will get the 2 secant x. Differentiate the secant into tan x. So the number of terms are 2. Then next differentiation, the number of terms are 4, 6. It goes on increasing. To avoid that, write this secant square as a tan x, that is the given function tan x. Then write the y of x. So I write this y dash of x term, the secant square, as a 1 plus tan square x. So y dash of x equals 1 plus, using, take this term as equation star of x whole square, using the equation star. Next differentiation. To make the differentiation easy, I consider this function as a given one, y of x. So the next differentiation, the one differentiation, since it is constant, the differentiation is 0. So y of x whole square, the differentiation of y of x is a 2y of x. Then differentiate y, you will get the y dash. Then put x equal to 0 in this step itself. So I take the y double dash of 0, this equals, since the 2 into y of 0, so the y of 0 equal to 0, since you have the product, the whole term becomes 0. So the y double dash of 0 equals 0. Next, the third derivative of x, keep the 2 outside since it is a constant term. No need to write the y of x, just write y and y dash, that's also enough. So y, take the product rule, the y dash of x differentiation y double dash of x plus y differentiation y dash, keep the second term as it is. I taken the product rule, first term differentiation of second plus first term differentiation, I kept the second term as it is. So in this step, put x equal to 0. So the third derivative of 0, this whole term is multiplication of 2. Since the y of 0 is 0, you have to write the y of x instead of y. Simply I written y. So y of 0 equal to 0. So we will get the 0 in the first term. Since the y dash term is 1, y dash into y dash, 1 into 1, you will get the 1. So the third derivative of 0 equals 2. So minimum 3 terms in a series how to consider. So you got only the 2 terms. Take the one more differentiation. The fourth derivative of x. Here keep the 2 outside as it is. Take the product rule between these two. So y, differentiate y double dash, we will get the y third derivative plus y differentiation is y dash, y double dash, this is for the first term. Second term, you have the y dash 2 times, so the y dash whole square, the differentiation is a 2y dash, differentiate y dash, you will get the y double dash. This the whole term is multiplication of 2. So first you take the product rule for these two, take a bracket, Next y dash, you have the 2 times y dash whole square, differentiate that 2y dash, the differentiation of y dash is y double dash. Next in this step itself, put x equal to 0, you have to check the x values, that is fourth derivative value. The first term 2 times of, since the y of 0 equal to 0, the first term you will get 0. Next second term, y double dash is also 0, so this term is becomes 0. Next third term is 2 multiplication of y dash and the y double dash. Since the y double dash is 0, you will get the 0 in the fourth derivative also. So take the one more differentiation, differentiate the term and put x value equal to 0. So you will get the term as 16. So the fifth derivative of 0 equal to 16. So you know the Maclaurin series expansion. First term y of x equals y of 0, x by 1 factorial, the first derivative of 0, x square divided by 2 factorial, the second derivative of 0. So the y of x, the given it as tan x, first term 0, x by 1 factorial is 1, the y dash of 0 is 1, x square divided by 2 factorial is 2, the second derivative of the term is 0, x cube divided by 3 factorial is 6, the third derivative of the term is 2, plus x power 4 divided by the 4 factorial is 24, the fourth derivative is 0, x power 5 divided by 5 factorial is 120, the fifth term is 16. So simplify these terms, you will get the tan x series. So the tan x equals, so there is the expansion of the tan x using the Maclaurin series. So next problem is e power x sin x. How to expand the e power x sin x using the Maclaurin series? As usual, you consider the given series as y of x, goes on differentiating till you get the terms. If they ask to find the till the third derivative or fourth derivative, take up to the fourth derivative. So the first, let, as usual, you take the given term as, let y of x equals e power x sin x. This is the given term. So check the given function, that is put x equal to 0, e power 0 is 1, sin 0 is 0. So you will get the first term itself is 0. Since the sin 0 is 0, the multiplication of e power 0 will get the 0. Same the second term, differentiate this. Since the one is exponential, the another one is trigonometric, take the product rule. So the first term e power x, sin x differentiation is cos x, plus e power x differentiation e power x sin x. So to make the differentiation easier, so take this term, keep this equation as the equation star. So from the equation star, you can also write this term y dash of x equals e power x cos x, plus for the e power x sin x, using the equation star, you can write this equation as y of x. This is from the equation star. Keep this as equation 1. For the next differentiation, y double dash of x, again take the product rule for this, keep the first term e power x, the cos x differentiation minus sin x, plus e power x differentiation is e power x, keep the cos x as it is. Next y of x differentiation y dash of x. First these two are the product rule. The last one y of x differentiation is y dash of x. Next again using the equation star and the equation 1, you can simplify this term. So using the equation star, you can write the e power x into sin x as the y of x. Since you have the negative sign, you will get the minus y of x plus, from the equation 1, for e power x cos x, for this term, you can write the y dash minus y of x. So, for the second term, y dash of x minus y of x using the equation 1 plus keep the last term as it is. I use the equation star and the equation 1. Next, simplify this before going to the next differentiation. So, since you have the y dash and the y dash 2 times, you can write the 2 y dash of x. Next term minus y of x, since you have the minus y of x, we will get the minus 2 y of x. So, to make the differentiation easier, you can substitute the given terms using the given, that is functional value, that is y of x, y dash and the y double dash. For the next differentiation, the third derivative, you can simply differentiate this. It is 2 times of the y dash differentiation is a y double dash. For the next one, y of x differentiation is y dash of x. Up to third derivative in a series. So, check whether you will get the third derivative or not. For the second term, the y dash of 0, put x equals 0. So, e power 0 is 1, the cos 0 is 1. The second term, since you have the sign, you will get the 0. So, you will get the answer as 1. Similarly, for the second derivative, I take this term. For the second derivative, the y double dash of 0, it is 2 times of, the y dash of 0 is 1, y of 0 is 0, you will get the 0 for the second term. So, the third derivative of 0, you will get the answer as 2. Similarly, the third derivative of 0, it is 2 times of y double dash. Since you have the y double dash is 2, you will get the 4, minus the y dash is 1, the 4 minus 2, you will get the 2. Now, we got the 3 terms in a series. You can substitute in a Maclaurin series. You know the Maclaurin series, I will substitute directly. So, write the Maclaurin series. The first term, y of x, given the y of x is e power x sin x equals y of 0 is 0, x by 1 factorial, y dash of 0 is 1, x square divided by 2 factorial, the y double dash of 0 is 2, x cube divided by 3 factorial, the third derivative is also 2. Simplify this, you will get the e power x sin x. First term is x, the second one (3 factorial). There is the expansion of e power x sin x. Similarly, you can do for e power x cos x and e power x tan x. So, before differentiating, first you simplify the function like this using the given term, that is y of x, y dash of x. Then you differentiate to make the problem as simplest. Then you can take the put x equal to 0, you will get the terms. 3 terms in a series you have to substitute, you will get the e power x sin x is the series. Next problem, log of 1 plus sin x. Suppose they asked to find the log of the trigonometric function, that is log of 1 plus sin x using the Maclaurin series. As usual, you take the function as the y of x. So, I consider the term, let y of x equals log 1 plus sin x. Next, put x equals 0, y of 0 equals log 1 plus sin 0. So, you will get the log 1 is 0. This is the first term. For the second term, for the second derivative, y dash of x, Log x differentiation is 1 by x, so it is 1 by 1 plus sin x. Differentiate the sin 1 plus sin x. For the 1 you will get the 0 since it is a constant term. Sin x differentiation cos x. So log 1 plus sin x, log x differentiation 1 by x. For the 1 you will get the 0 since it is constant. Sin x differentiation is cos x. For the next one, before that, put x equals 0, y dash of 0, cos 0 is 1, denominator 1 plus sin 0, you will get the 1. So the y dash of 0 equal to 1. For the third derivative, so the second derivative, the y double dash of x, since you have the cos x denominator 1 plus sin x, apply the quotient rule. So I take the denominator square, you know the quotient rule, the denominator square. So 1 plus sin x whole square. Write the denominator 1 plus sin x. Differentiate the numerator minus sin x minus, write the numerator cos x. Differentiate the denominator. For the 1 you will get the 0. Sin x is a cos x. So repeat once. For the denominator square, write the denominator. Numerator differentiation is minus sin x minus numerator the cos x. Differentiate the denominator. You have to differentiate 1 plus sin x. For the 1 you will get the 0. Sin x differentiation is cos x. Simplify this. So first you multiply this negative minus sin x. So sin into sin, you will get the sin square minus cos square x, denominator 1 plus sin x whole square. Since you know the sin square and the plus cos square term equal to 1, take the negative sign outside, we will get this term as 1. So we will get the term minus sin x. If you keep the negative sign outside, sin square plus cos square, the term is 1, denominator 1 plus sin x whole square. This equals, so take the negative sign outside, you will get the 1 plus sin x, denominator 1 plus sin x whole square. These two get cancelled. So the second derivative of y of x, so y double dash of x equals minus 1 divided by 1 plus sin x. For the next differentiation, again you take the quotient rule or you just cross multiply the 1 plus sin x. So I just cross multiply the 1 plus sin x. Y double dash of x, you will get the minus 1. So y of 0, you got the answer as 0. The y dash of 0 is 1. You check for the y double dash of x. So the y double dash of 0, 1 plus 0 is 0, this multiplication, so you will get the minus 1. Then take the next differentiation. So these two are the different functions, so I take the product rule. First term 1 plus sin x, y double dash of x differentiation, third derivative of x plus 1 plus sin x, the differentiation is cos x. Keep the second derivative of x as it is, minus 1 differentiation 0. Then check the third derivative. So the third derivative of 0, here 1 plus sin 0 you will get the 1. The third derivative, the cos 0 equal to, the cos 0 is 1. The second derivative, the term is minus 1. This equals 0. So we will get the third derivative of the given function equals plus 1. Since you got the three terms, you can write the Maclaurin series expansion. So I directly write the Maclaurin series for log 1 plus sin x equals, first y of 0 equals 0, x by 1 factorial, the y dash of 0 equals 1, x square divided by 2 factorial. The y double dash is minus 1. X cube divided by 3 factorial. The third derivative is plus 1. So we'll get the log 1 plus sin x using the Maclaurin series. The first term is x, second one x square divided by 2 factorial, third one x cube divided by 3 factorial. This is the series expansion of the log 1 plus sin x. The next problem, suppose they asked to find the square root of the given function, that is 1 plus sin 2x. So using the Maclaurin series, I usually consider the term that is y of x, the given term as y of x, it is 1 plus sin 2x. If it goes on differentiating, you know the square root, that is root x differentiation is 1 by 2 root x. Again you will get the square root. For the next differentiation also you will get the square root. To avoid that, I just write this 1 as, so using the formula, so take this term as y of x equals square root of, write the 1 as sin square plus cos square, sin square x plus cos square x plus sin 2x, you can write it as 2 sin x into cos x. So 1 you can write, the sin is sin square plus cos square, the sin 2x is 2 sin x into cos x. So now it is a square plus b square plus 2ab formula. So you can write the term as y of x within the square root, it is a plus b whole square sin x plus cos x whole square. Now you can cancel the square root with square. So we'll reduce the given function, the y of x, as the sin x plus cos x. Now you can take the differentiation till the 3 terms, minimum 3 terms in a series. So the first differentiation of this, the y dash of x equals, the sign differentiation is cos x, for the cos x is minus sin x. Just a single term you have, you can take the differentiation easily. So the second derivative for the cos x is the minus sin x you will get the cos x. Third derivative, minus sin x, it is minus cos x, for the cos x is a minus sin x, you can write the plus sin x. Next, put x equal to 0, y of 0 equals, for the sin 0 you will get the 0, cos 0 is 1, so the y of 0 equals 1. Second term, the y dash of 0, cos 0 is 1, the sin 0 is 0, so we will get the answer 1. The second derivative, the y double dash of 0, sin 0 is 0, cos 0 is minus 1. Second derivative. The third derivative, cos 0 is 1, since we have the negative sign, we will get the minus 1. So you got the 4 terms in a series. You can write the Maclaurin series expansion. The given term is the square root of 1 plus sin 2x, this is the y of x. Okay, this is the series. Suppose they asked to find the exponential with inverse trigonometry, that is e power sin inverse x. So using the Maclaurin series, first you take the given function as the y of x equals sin inverse x. Next to differentiate this, the y dash of x equals, the e power x differentiation is e power x itself. So you will get the e power sin inverse x. Sin inverse x differentiation 1 by square root of 1 minus x square. Next, for the second differentiation, so you can multiply this, cross multiply the term square root of 1 minus x square to the left side, or you can apply the quotient rule, that is also possible. So to make the differentiation as simplest, so using this, the given function, take this as equation star. First to cross multiply this, root 1 minus x square, y dash of x. I take the e power x sin inverse x as the y of x. So using the equation star, I can write this term as y of x. Then for the next differentiation, for the LHS part, you can take the product rule. So product rule, keep the first function 1 minus x square, differentiate the second one, y double dash, plus root x differentiation 1 by 2 root x, 1 minus x square differentiation, for the 1 you will get the 0, x square you will get the 2x, y dash of x as it is, the y of x differentiation y dash of x. So to avoid the square root of 1 minus x square, multiply root 1 minus x square on both the sides. Multiply the term. For this first term, root 1 minus whole square into root 1 minus whole square. So you will get the 1 minus x square is the term, y double dash of x. The second part, these two get cancelled and the 2 also get cancelled. You will get the minus x y dash of x. For the third term, the RHS part, y dash of x root 1 minus x square. For the y dash of x root 1 minus x square, this part you can substitute y of x using the equation 1. So keep this as equation 1. You substitute this as the y of x. This is from the equation 1. So simplify this. You will get the next, for the next differentiation, you simplify or you can take the differentiation directly. So before that, you check the, put x equal to 0, you check the given terms. So y of 0, sin inverse 0 is 0, e power 0, you will get the term as 1. For the first differentiation, so y dash of 0 is also equal to 1. Second derivative, you have the second derivative here, y double dash of 0. Since you have the multiplication of x, the term is 0, equals y of x. So y of 0 equal to 1. This implies the second derivative also equal to 1. If you want to continue till the third derivative, you can consider this as the y of x, this part, using the equation 1. Then you can continue till the third derivative. Or else, since you got 3 terms in a series, you can write the Maclaurin series. So the Maclaurin series, they given the function as e power sin inverse x, y of 0 equal to 1, x by 1 factorial, y dash of 0 is also equal to 1, x square divided by 2 factorial, y double dash is also equal to 1. This is the series for e power sin inverse x. Thank you.